The aim of continuous delivery is to allow us to repeatably and reliably deliver software into the hands of our users. And we do that through build, deployment, and test automation. You can't achieve repeatability without really controlling the variables. And one of the key variables that we must control is the infrastructure that supports the systems that we build. So how do we take control of that infrastructure? What is infrastructure as code? Hi, I'm Dave Farley of Continuous Delivery. Welcome to my channel. If you haven't already, please do hit subscribe and like if you think that's appropriate. That way we can keep you up to date of new releases to the channel. Have you ever said, "It worked on my machine," to anyone? If you have, then you need infrastructure as code. In this episode, we're going to talk about three strategies for defining infrastructure as code and the pros and cons of those strategies. We're going to talk about 5 principles that underpin the ideas and 7 practices that will help you to achieve infrastructure as code. A lot of the ideas for today's episode are based on the work of a friend of mine, Keith Morris, which he wrote in his fantastic book, Infrastructure as Code. There's a link down below which you'll be able to follow if you're interested in that book, which I strongly recommend. Infrastructure of code is the attempt to use software techniques to configuration manage our infrastructure. What do we mean by infrastructure? If you think about all of the stuff that needs to be in place to support the software systems that we build, the operating systems, the programming languages, the databases, messaging services, web servers, whatever they may be, that's the stuff that we're talking about today. We're trying to, those things are really a dependency of the systems that we build. And therefore, if we want genuine repeatability and reliability, we need to be able to take control of those things. We want to gain control by making the provisioning and updating of our infrastructure an automated thing. Why do we want to do this? Well, the first principle of continuous delivery says we're trying to create a repeatable, reliable process for releasing software. And for that, we must automate to get the repeatability. In order to automate, we must take control of the variables. We want to be able to automate things, and each time we carry out that automated process, we want to achieve the same result every time. If we start down this road and we start thinking in this kind of way, that automation enables the repeatability and reliability, but it also allows us to version control the infrastructure, which means that we can do things like if we make a change and that change is wrong in some way, we can step back to a stable, known version that was working before. It also opens up the opportunity for us to be able to test those things and maybe evaluate whether that change is going to do what we hope it's going to do or not. And lastly, it gives us deployment flexibility. If we've automated all of these things, it's relatively easy to reproduce a functioning environment somewhere else for the systems that we build and all of their infrastructure. So what sorts of practices does this take? We need to automate the provisioning of the infrastructure. The environment in which our software operates is the dependency of the system itself. A good thought experiment to just kind of put this into place in your head is to imagine running a version of your software that was in production a year or two ago and deploying that to a local test environment today at the push of a button. If you can do that, then your configuration management is excellent and your infrastructure as code is well sorted out and in place. If you can't do that, there's room for improvement. So, what are my 3 strategies for defining infrastructure? The first strategy is kind of ad hoc manual configuration of environments. If you are configuring your environment by going into an administration console and interacting with the admin console in that way, that's what we're talking about. The next step up from there is something called configuration synchronization. We're going to create a model of our configuration, and we're going to synchronize with that model. We're going to implement that model. We're going to execute that model for each deployed environment that we're trying to recreate. And the last one of these strategies is called immutable infrastructure. And this is where we're going to completely recreate the necessary infrastructure for our systems or services from scratch every time we deploy. So let's look at each one of those in turn and look at the pros and cons of those. So the ad hoc description, so the ad hoc approach is about manually crafting the administration or the configuration of every server. What are the pros for this approach? Nothing, not at all, nothing at all. There are no advantages to this approach. It's a terrible idea. Just don't do it. Against, this is the most common approach. Still, this is what most organizations do. They hire people to manually interact. One of the biggest software losses ever, the Knight Capital disaster where they went bankrupt in 45 minutes, was down to this kind of configuration error where one server was different to all of the others because it had been manually configured. This does not allow you to have repeatability. Each server that you create will be unique and slightly different. For that reason, this pattern is sometimes referred to as a snowflake, the items or a work of art. There's poor or no configuration management in this approach. Occasionally, in more bureaucratic organizations, they will try to implement paper procedures to make this a little bit more repeatable. If you've ever worked in one of those environments and followed those sorts of procedures, if you're anything like me, what usually happens is you get halfway down the list and now the system doesn't bear any relation to the thing that you're supposed to be doing next. This is a low quality approach. Next, configuration synchronization. This is where we keep a central model of the configuration and it's reproduced, usually on a timed basis at each point where that configuration is needed. The big advantage of this is it gives us the ability to create a declarative definition of what we want our servers and infrastructure to look like. The central model can be version controlled. That means we can kind of replay this and make small changes. Changes to many servers can be simple and consistent. We can scale those changes out. If we have a definition for a database server or a web server, we can just replay that every time we need one of those things, and we'll get exactly the same thing every time. It's testable. We can start thinking about writing tests or evaluating each step in the change in the configuration to understand whether it works or not. This approach works best when there is no manual access allowed to the servers. The danger with this approach, if that's the appropriate phrase, is that you might inadvertently change one of those servers and that doesn't get overwritten by changes, and therefore the configuration of those servers tends to drift. With these automated approaches, it's much more efficient to take people out of the way. If manual access is allowed to those servers, that configuration can drift. The other slight downside to this approach is that most of the models that you build don't really handle deletions very well. You can imagine having a script that says add a web server, and then you delete the line that says add the web server, but that doesn't tell the server that you knew about it and that you should take it away. So that the impact of that is that this approach can work very well, but relies on good team discipline to keep it working, making sure that people aren't going in and tinkering with the servers once they've been configured through the automated process. The last of the three strategies is immutable infrastructure. In this approach, every time we deploy the system, we're going to recreate the infrastructure from scratch. The huge advantage of this is again, you've got the declarative definition, the central model can be versioned, but the big change, the big idea is that it's definitive. Every time we deploy, we know exactly what we're going to get. If somebody had gone in and inadvertently changed one of the servers, next time we deploy, those changes will be blown away and the server will be back to where we want it to do as is defined in the script. Again, this is very scalable. We can have one copy of the immutable infrastructure, and we can reproduce that hundreds or thousands of times if we want. It's testable. It's version controllable. This is a very, very powerful approach. The only real downside to immutable infrastructure is that it can be slow to provision. If you think about what it takes to reproduce the entire infrastructure for somewhere from scratch, you're shifting a lot of bytes around a network or from storage somewhere. And so inevitably there's going to be some cost to that. So you need to be thoughtful about those sorts of costs and how to manage them. Modern technologies go a long way to assisting with some of those patterns. Things like Docker and so on have a built-in layered version control system that will kind of incrementally farm out changes to ease this problem. But it's something to take into consideration in some circumstances. So, of the three strategies, there are only two that are useful. So certainly avoid manual ad hoc configuration. But the other two can be useful in various contexts. They share, though, a bunch of principles, common principles between them. So let's think about those now. There are 5 of these common principles, and afterwards we'll talk about how to apply different practices, 7 different practices to achieve those principles. So the first of the principles, systems can be easily reproduced. We talk in infrastructure as code circles, people sometimes talking about treating your servers as cattle rather than pets. We're not going to be too attached to any individual server because we can kind of throw it away and recreate it. The systems are disposable. We can just discard them and recreate them very cheaply indeed. They're consistent. If we create one from the same definition, we're going to get exactly the same environment every time. So the processes around these are repeatable, and the systems are always changing. Our assumption is this technique is there to allow us the freedom to evolve our systems over time and refine the configuration of our systems along with everything else about the systems that we create and operate. So those are the 5 principles that we're trying to achieve. So what are the practices that help us put those things into place? So first, use definition files. Make sure that your infrastructure is soft. We're trying to convert the definition of this infrastructure from switches or hard admin consoles into some kind of a script that we can version control somewhere. If we do that, we get self-documenting systems. We're going to script everything, and the docs then can't be out of step. We don't have some kind of written Word document. We have a script that executes, and that's a very high standard in terms of repeatability and reproducibility, and in terms of the audits of what actually went on. We want to take control, and so we want to version all of the things. We want to version every aspect of the systems that we're responsible for. And if we're going really take this really seriously, we can start thinking about continuously testing the systems and processes associated with all of this. We want to make changes in small steps, and version control is a key enabler of those small steps. If I'm working in small steps and I take a misstep, I can easily go back to a more stable position, and so on. We want to keep services continuously available for most modern systems, and infrastructure as code techniques are key to enabling that repeatability and reliability of service, as well as just the changes to the service. And finally, we want to prefer unattended execution over interactive use. If your build, deployments, configurations, management scripts require somebody to go up and say yes to a question or type in the IP address of a server, that's not what we're talking about. We want to be able to have a push button that will do everything and trigger the deployment and configuration of everything. So that's my 3 strategies, 5 principles, and 7 practices. So what is it that we're really trying to achieve here? What's the real outcome? We're trying to version everything that our software depends upon so that it's reproducible. We're going to be versioning operating systems, the language that we're using, the libraries that we depend on, scripts that we're using, the relational database management system and its configuration, messaging infrastructure, web servers, network switch configurations. Anything that you can think of that has an impact on the environment in which your software operates, we want to take control and be absolutely definitive about the configuration and deployment of that system. Our goal is that every bit and byte in production is the one that we intend, and every bit and byte that we put into production is reproducible. Every change to production flows through a deployment pipeline. Every change to production is version controlled. We're going to automate every aspect of these things. I like to advocate for my clients and on the projects where I work that we try and eliminate as far as we can human access to production systems. Yes, we may have tools that allow us to look at log files or give us telemetry from the systems, but we don't have system administrators going in and tinkering with the production systems. There is no technical right access to production systems in this worldview. Infrastructure code is not unique to the cloud. It's a common idea that infrastructure as code is a cloud technique. I first began practicing it before the cloud was a common thing, but the cloud makes it more obviously desirable. It's hard to imagine somebody working on Amazon or Google's scale having an army of manual environment configurators or admin people to look after their services. That would be ludicrous. So, of course, at those sorts of scales, they're going to automate all of those things. So infrastructure code is kind of obvious when it comes to the cloud. The most effective strategy for cloud provisioning is immutable infrastructure. I would strongly recommend that you do that by default. It enables elastic scalability, just-in-time provisioning, dynamic configuration of systems, and so on, once you start taking these things seriously. If you're going down that route, I strongly consider that you look into ideas like blue-green deployment and canary releasing. We'll probably talk in more depth on both of those topics because they deserve more time in future episodes. In Keith's wonderful book, he on one of the pages, he describes this wonderful model of the configuration management fear spiral, which I've spoken about in a previous episode. This spiral goes as follows. I make configuration changes outside of my automated tools. My servers are inconsistent. I'm afraid of running my automation on my servers because my servers are inconsistent. And then you go round and round and round that spiral. So we need to look for ways in which we can kind of break that spiral of fear. We need to face our fears and we need to address those. Work to reduce and then eliminate all manual tasks involved in your configuration management. Do this as a series of small steps. There's some wonderful advice in Keith's book about how to automate those things. Script those steps and figure out how to do that sensibly. Version control the scripts. Use standard version control tools. There's no reason why this has to be a different kind of tool. Get it to the level where you can put it into Git or whatever other version control system you use, and that's a good place to be. Apply continuous delivery thinking to infrastructure. As I said earlier, always put your infrastructural changes through a deployment pipeline. And yes, I have written a deployment pipeline that allowed me to test changes to deployment pipelines in the past. And it was a very effective strategy. We even had deployment pipeline unit tests for the stuff that we were built, the infrastructure as code changes that we were making. In summary then, it's all about controlling the variables. As I said in an earlier episode, I think that controlling the variables is one of those key steps that takes us beyond just process and practice and into the realms of science and engineering. If we want to be disciplined about this stuff, we need to take these ideas seriously. Remember the infrastructure is a dependency of your system. Take that idea seriously and start managing that dependency effectively through automation and version control. If you have any great examples, or for that matter, disastrous examples of where you applied these 3 strategies, please do let us know in the comments below. Thank you very much for watching.